This is an introduction to C++ variables. When a program runs, they need to store values. So just for example, if you're playing a game, you've got to store the hit points of the player, and you've also need to store the hit points of each of the enemies. You've got to store the X, Y, and Z location of everything, and so forth. So in C++, before you can use a variable, you must declare it. And when you declare it, you give it a name. But if you do not declare it, you'll see an error message. Let me just give you an example of that first. I'm going to see out the value of age, but I have not declared age. So I'm going to build and run, and you'll see that I get an error message that says age was not declared. So what we have to do is we need to declare it, and the way we declare it is we tell it what type of variable it's going to be. I'm going to start with an integer. Probably the most common variable type is an integer. And of course, an integer is a number without a decimal point. So by doing this, int age, I have just told the compiler that to reserve some memory to store a value and name it age. So whenever I access age. And so now I can give age a value, and now I can output the value of age, which will be 20. So I'll build and run, and there it is. Age is now equal to 20. Okay, now here's the interesting thing about this is where some programming languages might be different. If I do not give a value of age, if I do not assign a value of age, some programming languages will warn you, like Java, that you haven't initialized a value. Other interpreted languages will probably just assign it to the value of 0, but C++ doesn't do that. Actually, what happens if you do not assign a value is that it will actually just pull whatever value happens to be in that memory that it reserved. So this is just left over from something else, this value right here. It doesn't really have any significance. So you need to remember to assign a value. You can also assign a value on the same line so as you declared it. So here, int age, and then I can say equals to 25. So this declares the variable, and then this is an assignment statement, equals 25. So run it, and so now we've assigned the value of age, and then we've declared it and then assigned it a value in one line. Now you can also declare and assign multiple variables of the same type in one line. So let's go weight is equal to 150. So this is separated by a comma, not a semicolon. Remember, a semicolon goes at the end of the lines, and the comma right in here. Okay, so here I can output age is equal to that, and then I can output weight is equal to the value of weight. Okay, so let's run it. And there it is. Okay, so we can declare multiple variables of the same type in one line and assign them if you values if you want. And then remember, we can do additional assignment statements afterwards, or we can change their values afterwards because it is a variable, so it can be changed as many times as you want to in the program. So for example, I can say age is equal to age plus 1. And now, if you remember, there's a shortcut way of doing that, because when you add 1 to a variable, that is also called incrementing it. And the shortcut way to increment a variable is to do a plus plus. And then let's subtract 1 from weight. I could go weight minus minus. So that's the same as weight is equal to weight minus 1. You're decrementing weight. Okay, so let's build and run it, and there it is. Okay, good. Now, let's say that you want to have the user input values for age and weight. In that case, you probably do not want to initialize a value. So I'm just going to declare age and declare weight. And then I'm going to ask the user to enter a value. Enter your age, like that. And then I'll do a cin statement followed by 2 greater than signs into the variable that you've already declared. So remember that this pauses the program, waits for the user to enter a value on the keyboard, and then as soon as they press enter, it throws that value into the memory that's storing age right there. Okay, and let's do the same thing for enter your weight, and then cin into weight, like that. Okay, so now when I run the program, enter your age, 30, I wish, enter your weight, and so then it stored those values into the variables age and into weight. Okay, so, and again, this is just remember, an integer is a variable that stores a number without a decimal point. Okay, now, if you want to store a number with a decimal point, so let's just, then you'll need, there's a couple of variable types for that. One is float. Oh, in fact, watch what happens here. When I run this, if I enter age is 30.5, I forgot to enter weight. See, actually, by putting a point, it looks like it caused me to skip over the weight. So that's a problem. If you need the user to enter a decimal point, then you'll need to use one of 2 variables. One is a float variable. So float is a number with a decimal point. So now I can enter 30.5, and then I can enter 150.9, for example. Okay? And so now, let's take a look at legal variable names. Let's just simplify this a little bit. Getting rid of some of this stuff. Okay, so age is a legal variable name. A variable name needs to begin with a character, a letter of the alphabet, and they are case sensitive. So this is a different variable than this one, because this one has a capital A, that one has a lowercase a. They are different variables, store different values. But now I would recommend not doing that in a program, because that can be confusing right there. Okay, so they are case sensitive, and you can have a number in a variable. Okay, so see, this one compiles okay. Well, let's simplify the program a little bit more. This one compiles okay, age 1, but you could, again, it needs to begin with a letter. I can't put the number 1 in front of age, because that will be an error. And right here, it changed colors to a numeric value right here. Told you that that wasn't good. The editor did. And now, you cannot put, as far as symbols, you can only use an underscore. So I can put age underscore 1, and that will compile just fine. But you can't use any other symbols. So, for example, a dash, it thinks that dash is a minus sign, so you can't use a dash. So underscore is the only symbol that you can use within your variable name. You know, you can't do anything else like an @ sign like that or anything. Just an underscore is legal. Okay, now, one common thing that you see, one common naming scheme of variables, you should use, if you just have a program that asks the user to enter their age and weight, you can name the variables age and weight. But usually you should think about naming variables something more descriptive. So just for example, let's go back to a game. Let's go player hit point. So you can have multiple words in there. And so then, say is equal to 100. Then I can have enemy hit points equal to 100 or something like that. So you can put multiple words in one name, or if you want, you can put an underscore like that. Okay. So now, that's, here's variable names, legal variable names, and ones that aren't legal right here. Okay, now let's look at how these variables are being stored on the computer and all the different variable types that we have. Okay, so we just talked about an int variable. And an int variable is actually being stored in 4 bytes of memory. So when you declare an int variable, your compiler reserves 4 bytes of memory to store the value. And now I'm going to open up my calculator here. And 4 bytes has 32 bits. And so actually 4 bytes, if we take 2 and raise it to, if we raise it to 32nd power, that tells us that 4 bytes can actually store this many numbers right here. Okay, so that's approximately 4.3 billion. Okay, but what happens is an int can also store negative numbers. So what they do is, okay, so instead of being able to store a number from 0 to 4.3 billion, an int can store a number from, we split this range in half, so an int can store a number from about negative 2.1 billion to positive 2.1 billion. And the same thing with a short. A short variable type is an integer, but it only takes 2 bytes of memory, and these are the legal values. So 2 bytes of memory is 16 bits. So if I do 2 and raise it to 16 power, that gives us 65,536 different numbers. So what they do is they split that range, and so allows us to store from negative 32,000 to positive 32,000. Okay, so now one more thing that's interesting about this programming language. Let's declare a variable, a short variable, which is a short integer, and I'll just name it A, and I'm going to make it equal to the largest number, 767. Remember, you can't put commas when you're putting in a number. I'm going to make it equal to the largest number a short variable can store. And then let's see out the value of A. Okay, so right now it should run fine, and it just outputs that number right there that I put in, 32,767. But now let's increment that variable. Okay, so what we're doing, this is already storing the largest number that 2 bytes or a short variable type can store, 32,767. Now we're incrementing it. So now the question is, what happens? Does it give you a runtime error, a syntax error, or something else? So this is where it might not be intuitive, but what happens is it actually wraps around and now becomes the smallest number that a short variable can be. Okay, so I would actually call this a logic error. Logic error means you're not getting the correct, your program isn't outputting the correct result, because that is probably not what you intended right there. Okay, so and this is kind of part of C++ being very efficient. Actually, on the CPU, when you increment a memory address or a register in a CPU, and it's already the biggest number it can be, it goes back to 0. And so that's kind of what's going on right here. Okay, so that's something to remember. So you need to make sure your variables are, you're using a large enough variable that can store that data. Now, should you use an int? Let's say that you're storing someone's age. Well, an age, I mean, the oldest person is on Earth is probably only around 120 or something like that. So you can certainly use a short that stores the number that big. But a lot of programmers may just do an int instead of a short just because they're just used to it. See, computers have a lot of memory, and in most cases, saving a couple of bytes is not a big deal. Only if you're doing an array, which I'll cover in another video, where maybe you're storing millions or billions of variables or something like that, would saving a couple of bytes really matter. So a lot of programmers won't bother, with making a short. They're just kind of used to typing int like that. Okay, so now some other variable types. So an int can store a number up to 2.1 billion. But then here is we've got a long variable type that stores 8 bytes, and it can store a much larger number. This is up to whatever that number is. And now we also have unsigned variables. So for example, an int stores a number from -2 to +2 billion, takes 4 bytes of memory, whereas an unsigned int, which also takes 4 bytes, can store a number from 0 to 4 billion. So we're not splitting the value in half to be able to store negative numbers. You just got the full range of the memory to store a positive value. I'd say most programmers don't always use them. Some will use them simply because to guarantee that a negative number will not be stored in there. But if so, for some reason, you need to be able to store a little bit larger number than 2.1 billion, but less than 4.3 billion, then you can do an unsigned int. So you would just do up here, you'd go type unsigned int. Just call it A is equal to. Now I could store 3 billion. 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, which should be 3 billion. So let's run it. And so now we're able to store 3 billion. Whereas if I had stored that without being an unsigned, then you'll notice it wraps around and you'll see that we have a negative number right here. Okay, so now another thing I wanted to show you is let's talk about float variables. We've got 2 float variables. The float takes 4 bytes of memory to store the value, whereas a double takes 8 bytes. And they both can store a number with a decimal point. In fact, what floating point means is that the decimal point can move around. See, in some really old programming languages like Fortran, they had fixed decimal point variables. So you could, for example, store a number with 2 decimal points only. So 3.14 is what you could store. But with a floating point, that means that you could store the value as 3, which is no places past the decimal point, 3.14, 2 places past the decimal point, 3.1415, 4 places past the decimal point. And so so that's where the term floating point comes from. And actually double is a double-sized floating point variable, so the decimal point can move around. Now, I didn't put the maximum and minimum values that they can store because that's going to depend on how many places past the decimal point. Okay, now one thing I go over in my assembly language programming class in a little more detail is about how these variable types are being stored. They're not actually being stored as exact values. They're actually being stored as an estimation. It's kind of interesting how they're actually stored on the computer, and that's for the speed of processing for the CPU. But because of this, occasionally you can see a floating point error. Let's take a look at this program right here. Okay, so I've declared a variable float A and given it a value of -1.0. Now I'm going to add 0.2 to it 5 times. So now you would think that the value of A should be 0, but watch what it outputs. It's in scientific notation, but it's actually a value. It's almost kind of like a rounding error. It's actually a value very, very close to 0, because if you move that decimal point over 8 places, then it's a value very close to 0, but it is not 0. So, and that's what floating point errors are really not that common, but occasionally you'll see something like that. Now, if that really becomes an issue, then there's libraries out there with variable types and math operations that act on them that will actually store the values exact and not give you a floating point error like that. But they're going to execute a little slower, but a lot of times the speed doesn't really matter. Okay, so that's the float and the double. So if you need to store a number with many decimal points, places past the decimal point, then a double would be a good one. Now, there's actually only two other variable types built into C++, and that's a boolean and a char, short for character. So let's look at a boolean variable. So a boolean variable either stores true or false. It actually just stores a 1 or a 0. So if I do, if I'm going to make a boolean variable, name it married, is equal to true. Okay, but now it's actually just storing a 1 or 0. So if I output the value of the variable married, well, it's actually going to output a 1. Okay, right here. Because actually true is just a constant in C++ that's equal to the number 1. Okay, so this does the exact same thing right here. It's just sometimes when programmers are working with Boolean variables, they kind of like to, use the word true and false versus a 1 or 0. Okay, so you can do either one. And of course, it still takes a byte, even though you really just need a bit to store it. But I guess they can't break down the memory like that on the computer. Okay, now one other variable type is this character, stores one ASCII digit. So let's go char grade is equal to, now if you assign a value, you need to put it in apostrophes, not the quotations, but apostrophes, just like that. Okay, and so now I can output the value of grade, and there it goes. And so it's storing that value. You can also, it needs to be one character, you can also store a space, just like that. You can actually, if you look at an ASCII chart and know the number, the ASCII number that you want, you could actually store that value by typing in the ASCII number, not within the apostrophe. So, like, for example, the number 97, ASCII number 97, if you look in the ASCII chart, is a lowercase a. So I could actually assign a value just by typing in the ASCII number. Okay, so now that takes care of the char variable. Okay, now if you need to store text on a computer, words and sentences, you can't. A char just can store a single digit, a single ASCII character. And so what we do in that case is use a string. Now, a string is not one of the primitive variable types in C++. It's actually a class, but a lot of times we'll call it a variable type. So I'll just call it string name is equal to, in this case with a string, you'd use quotation marks. And so now you can store more than one character. So output name, and so now we can store more than one character like that. Okay, good. Let's see, I'm going to scroll down just a little bit more. Okay, here we go. Oops. I know I should edit this, but I don't feel like editing these videos. Okay, so now let's look right here. These exercises. Which variable type would be most appropriate for storing each of the following values? Keep it in mind to conserve memory whenever possible. And again, a lot of times you won't really worry about conserving memory, but just to do that. So someone's age, the best variable type. Well, since we already went over that, you can store it in a short instead of a 2-byte short instead of a 4-byte integer, and then you'd save 2 bytes of memory. The balance of a bank checking account. Well, whenever you work with currency, if you log into your bank account, you'll see that you'll have a decimal point. So you'll need to store that as a float. I would probably store it in a double, because maybe you have Elon Musk as one of your bank customers, and he has more money in his bank than a float would be able to store. Number 3, the yearly budget for the U.S. Well, the national budget is in the trillions. Okay, so if we're going to store numbers in the trillions, this one only, a long or an int only goes up to 2.1 billion. So you would need to do a long. Or you could do an unsigned long. Okay, the next one is a student's letter grade in a class, or we just went over that. You could store that using a char, a character variable. A car's odometer reading. How many miles? Well, what's the most miles that a car might have? Well, if you couldn't store it in a short, because cars can have over 32,000 miles on them. So you'd probably need to go for an int. It gives you up to 2 billion. I don't think there's any cars with more than 2 billion miles on them. Now, the next one is whether or not someone has a driver's license. In that case, you could use a boolean variable, true or false. The distance in miles to other stars in the galaxy. Well, that's getting to be a very large number, more than billions, so you're going to need to go for a long. Okay, and then the outdoor temperature. Okay, so the outdoor temperature could be negative, and so you could store it in a short, because that will store a negative. You wouldn't want to go unsigned because that won't store a negative, but you may want to do a float. Maybe you want a decimal point if you need more accuracy on that. Okay, so anyway, so that's just things to think about in choosing variable types, and I think that's all I wanted to cover in this video. Happy coding.